Okay, so it figures that in the first video in this lecture series, my PC would crash halfway through. So we're going to upload this as a separate video. So this is going to be section 6.1 part 2, which is multiplying and dividing rational expressions. I'm also going to avoid changing the ink color too much because I think that might have been what caused the crash. I honestly don't know what caused the crash. I'm working on my personal PC and this thing is old and really not great anymore. Again, I'm doing the best I can with the technology and time that I have. Anyway, so the next thing that we're going to be doing in this section is multiplying rational expressions. And multiplying rational expressions is going to involve all of the same rules as multiplying regular fractions. So we're going to recap how to multiply regular fractions. And you're going to find that the process... Oh no, hold on. Okay, we're not going to change the ink again. The process for multiplying fractions can involve a process called cross-reducing. And what cross-reducing is it is a process that involves you reducing the fractions as you go. Remember that order does not matter with multiplication. And you also might remember that when you multiply fractions, you do not need a common denominator. All you have to do is multiply the two numerators together and then multiply the two denominators together. So because of that, and because the two numerators are just going to end up being multiplied and the two denominators are just going to end up being multiplied, what you can do is you can look at the numbers in the numerators, so 2 and 15, and you can compare them to the numbers in the denominators, 3 and 8. And what you can ask yourself is, do any of the numbers in the numerators have any common factors with any of the numbers in the denominators? And it doesn't matter if they're in different fractions because order doesn't matter with multiplication. So yeah, there's a couple common factors here, starting with 2 and 8. 2 and 8 are both divisible by 2, so I'm going to divide them both by 2. So 2 divided by 2 is 1, 8 divided by 2 is 4. And 3 and 15 are also both divisible by 3, so there's a common factor there. So I'm going to divide them both by 3. 3 divided by 3 is 1, 15 divided by 3 is 5. Then I'm going to multiply the numbers that are left over in the numerator. So 1 times 5 is 5. And then I'm going to multiply what's left over in the denominators. 1 times 4 is 4. Now, if you are thorough and you make sure that you fully reduce everything that you possibly can in the beginning, you will not need to simplify anything in the end. So your final answer, if you do all of the cross-reducing that you can at the beginning, your final answer will be fully reduced. So when you're multiplying rational expressions, my suggestion is factor everything that looks even vaguely factorable before any multiplying or cross-reducing happens. Remember, you cannot cancel common terms. You can only cancel common factors. So go ahead and just factor everything in both fractions first. Then you're going to follow all of the same rules as multiplying fractions, multiplying the numerators, multiplying in the denominators. Now, when multiplying, you can cross-reduce. But you can only cross-reduce when you are multiplying. Do not cross-reduce when you are adding or subtracting. Cross-reducing does not work for addition and subtraction. Cross-reducing sort of works for division. We'll get to that in a little bit, but you can only cross-reduce when you are multiplying. So this is an example of a multiplication of two rational expressions. Before we even think about the multiplying, we are going to factor everything that we can possibly factor first. So for the numerator of the first fraction, x squared minus 9 is a difference of squares, so I'm going to factor it as x plus 3 times x minus 3. Then the denominator of the first fraction cannot factor any further, but I am going to put parentheses around it. Then the second fraction, the numerator of the second fraction cannot factor anymore, so I'm going to put parentheses around the x minus 6. And then in the denominator, yeah, there's only two terms, but you might notice that there's a common factor here. Both of these terms are divisible by 7, and both terms have an x in them. So I'm going to factor out a 7x out of both terms. So 7 divided by 7 is 1. Then when we factor an x out of x squared, we're left with x. 21x divided by 7x is plus 3. Then, just like with the multiplication of fractions that I showed you earlier, you take a look at all of the factors in the numerators and all of the factors in the denominators. And you're going to ask yourself, do any of the factors in the numerators have a common factor with anything in the denominator? And yes, a couple of these numerators have common factors with the denominators, and it doesn't matter if they're in different fractions. So, in this fraction, this x minus 3 can cancel out with this x minus 3. This x plus 3 in the numerator here can cancel out with this x plus 3 here, and you can do that because the 7x is being multiplied. You can cancel out common factors across multiplication. And remember, when these cancel out, they don't go away, they become 1. So let's multiply what's left over. So what's left over in the numerators, we have 1 times x minus 6, which is x minus 6. Then multiply the denominators together. 1 times 7x times 1 is 7x. And because we were careful to thoroughly cross-reduce at the beginning and simplify all that we could at the beginning, your final answer is in lowest terms. So we're going to basically do the same thing for this next one. We're going to factor everything that we can possibly factor, and then we're going to cross-reduce, and we can cross-reduce because we are multiplying in this problem. So in the numerator of the first fraction, I'm going to at least put parentheses around it. Then for the denominator of the first fraction, since this is a 1x squared, there's going to be an x here and an x here. And we're looking for two numbers that multiply to 45 and add up to 14, which are plus 9 and plus 5. Then, for the numerator of the second fraction, because that is a 1x squared, there is an x there and an x there. And we are looking for two numbers that multiply to positive 45 and add up to negative 14, which are going to be minus 9 and minus 5. Then the denominator of the second fraction cannot factor, but I am going to put parentheses around it. Then you are going to see if there are any common factors in any of the numerators with any of the denominators. So this x plus 5 in this numerator can cancel out with this x plus 5 here. And this x minus 5 can cancel out with this x minus 5. Now, the factors that are left over, this x minus 9 and this x plus 9, they're very similar, but they are not exactly the same. You could only cancel them out if they are exactly the same. And because these are not exactly the same, we can't do anything with this. We cannot cancel these out. So we're going to multiply what's left over in the numerator. So we have 1 times x minus 9 times 1 is x minus 9. Then in the denominator, x plus 9 times 1 is x plus 9. Now remember, do not cancel out the x's. Do not cancel out the 9's. They are common terms, not common factors. If you want to, you can leave the parentheses there to indicate that these parentheses do not match. These are not common factors. So this is your final answer. Now for this next one, we're going to basically do the same thing. We're going to factor anything that we could possibly factor, even if it's just taking out a GCF. And then because it's multiplication, we can simplify as we go and cross-reduce. So the numerator of the first fraction, since that's a 1x squared, there will be an x here and an x here. And we're looking for two numbers that multiply to positive 1 and add up to negative 2, which are minus 1 and minus 1. You do not have to write those as x minus 1 squared. We're going to cancel common factors out anyway, so there's no point in condensing them. Then for the denominator of the first fraction, there's only two terms, but you might notice that they have a common factor of x, so I'm going to factor an x out of both terms. Remember, there is a hidden 1 in front of here. So When we factor an x out of x cubed, we're left with x squared, and then plus 1 is left over for the second term. Then for the numerator of the second fraction, there's not much to do here because there are only two terms and they're not a difference of squares, that's addition. But there is at least a common factor of 4, so I'm going to factor out a 4 out of both terms. So we get x squared plus 4 divided by 4 is 1. Then in the denominator, since that is a 1x squared, there is an x here and an x here. And then we're looking for two numbers that multiply to negative 2 and add up to positive 1, which are plus 2 and minus 1. Now this is actually fully factored because remember, x squared plus 1 is not a difference of squares. This is a sum of squares. The sum of squares is not factorable. You might remember that from chapter 5. So x squared plus 1 here is as good as they're going to get. But what you can do from this point, because everything involved is multiplication, remember there's multiplication there with this 4 and with this x, you can cancel out common factors between any of the numerators with any of the denominators. So this x minus 1 in the numerator can cancel out with this x minus 1 in the denominator. This x squared plus 1 in the numerator can cancel out with this x squared plus 1 in the denominator. Now because nothing left over exactly matches, we're just going to multiply what's left over, and there's quite a bit left over. So over here we have 1 times x minus 1 times 4 is 4 times x minus 1. Remember, order does not matter with multiplication, so it doesn't matter if you put the 4 first or second. Then in the denominator we have x times 1 times x plus 2 times 1 is x times x plus 2. And it is completely okay if you leave it like this. If you want to distribute the numerator and denominator, you can. You can write this as 4x minus 4 over x squared plus 2x if you want to. I'm not requiring it. As long as it's fully reduced, you are all set. So then for this next one, before we get too far into the factoring, I want to draw your attention to the denominator of the second fraction. In the denominator of the second fraction, the x squared term is negative. Remember, if the x squared term is negative, before you do any other factoring, you need to factor out a negative 1 as a GCF first. So I'm going to pretty much leave everything alone. I'm going to just do one thing at a time. So we have x squared plus 7x plus 12 times, I'm even going to leave the numerator of the first fraction just alone for right now. We have x squared plus 3x minus 4. And I'm going to factor a negative 1 GCF out of just the denominator of the second fraction. So negative x squared divided by negative 1 is positive x squared. And then 4 divided by negative 1 is minus 4. Now that we've done that, now I'm going to get to work and factoring anything that I possibly can that looks even vaguely factorable. So numerator of the first fraction, x squared plus x minus 6. There's going to be an x here and an x here. And we're looking for two numbers that multiply to negative 6 and add up to positive 1, which are plus 3 and minus 2. Then for the denominator of the first fraction, x squared plus 7x plus 12, there will be an x here and an x here. And we're looking for two numbers that multiply to positive 12 and add up to positive 7, which are plus 4 and plus 3. Then numerator of the second fraction, x squared plus 3x minus 4, there's going to be an x there and an x there. And we're looking for two numbers that multiply to negative 4 and add up to positive 3, which are plus 4 and minus 1. Then this x squared minus 4 in the parentheses, that is a difference of squares. Remember, we took out a GCF, so it does need to stay there. But x squared minus 4 can factor as x minus 2 times x plus 2. So then any common factors with any of the numerators can cancel out with any of the common factors in any of the denominators. So x plus 3 can cancel out with x plus 3. X plus 4 can cancel out with x plus 4. X minus 2 can cancel out with x minus 2. Then from here, remember these all just became 1, 1, 1, 1. Let's multiply what's left over in the numerator. So in the numerators, we have 1 times 1 times 1 times x minus 1 is x minus 1. Then in the denominator, 1 times negative 1, we never got rid of that, times 1 times x plus 2 is negative 1 times x plus 2. And while there's mathematically nothing wrong with this, we do want to stay in the habit of not putting negatives in the denominator. So there's a couple of different ways that you can rewrite this. It doesn't matter where the negative goes, as long as the negative is somewhere, the entire fraction counts as negative. So you can put the negative on the side like this if you want to give us negative, x minus 1 over x plus 2. That is completely fine. Or if you want to, you can also put the negative with the numerator, so you can write this as negative times x minus 1 over x plus 2. And then if you want to, you can distribute the negative in the numerator to give you negative x plus 1 over x plus 2. Again, it doesn't really matter how you rewrite it. Just get in the habit of not having a negative in the denominator. Now, for dividing rational expressions, it's going to involve the exact same process as dividing regular fractions. So, dividing fractions can be summed up in a really simple phrase: keep, change, and flip. Some of you might remember learning something like this when you learned how to divide fractions, but if you haven't, here's what this means. You are going to keep the first fraction as it is, 1/2. You're going to change the division to multiplication. Then you are going to flip the second fraction, which involves taking its reciprocal. So the reciprocal of 3/4 is 4 over 3. As soon as you change the division to multiplication, now it is going to follow the rules for multiplying fractions. And remember, when you multiply fractions, you can cross-reduce. So this is what I meant by cross-reducing sort of works with division. As soon as you change the division to multiplication, now you can cross-reduce. So 2 and 4 here are both divisible by 2, so 2 divided by 2 is 1, 4 divided by 2 is 2. Multiply what's left over in the numerators. 1 times 2 is 2, over 1 times 3 is 3. And just like with multiplying fractions, you do not need common denominators when you divide fractions. So dividing rational expressions is going to involve the exact same process as dividing regular fractions. It doesn't matter when you factor. You can factor first and then do the keep, change, flip, or you can do the keep, change, flip first and get it out of the way and then start factoring. But at some point, before anything starts to cancel out, you do need to factor everything. Now, keep, change, flip involves you keeping the first or top fraction as it is, changing the division to multiplication, and then flipping the second or bottom fraction. As soon as you change the division to multiplication, then you can cross-reduce. So you can only cross-reduce when multiplying. Do not cross-reduce before you change the division to multiplication. Once it's multiplication, then you can cancel out any common factors in the numerators with any common factors in the denominators. I'm going to do the keep, change, flip first and just get that out of the way. This way I don't have to think about it anymore. And then I'm going to start factoring. So I'm going to keep the first fraction as is, x squared plus 13x plus 36 all over x squared plus x minus 12. Then I'm going to change that division to multiplication. Then I am going to flip the second fraction. So when you flip the second fraction, you're going to get x minus 3 over 1. Now I'm going to factor everything that I possibly can. So for the numerator of the first fraction, there is going to be an x here and an x here. And we're looking for two numbers that multiply to 36 and add up to 13, which are plus 9 and plus 4. Then in the denominator, there is going to be an x here and an x here. And we're looking for two numbers that multiply to negative 12 and add up to positive 1, which are plus 4 and minus 3. Now for the second fraction, there's no factoring to do, but what I am going to do is put parentheses around the x minus 3. Then any common factors in any of the numerators can cancel out with common factors in any of the denominators. So this x plus 4 can cancel out with this x plus 4. X minus 3 can cancel out with this x minus 3. And that looks like it's it. So let's multiply what's left over in the numerator. So x plus 9 times 1 is x plus 9. Divided by 1 times 1 is 1. Now, if all you have left in the denominator is a 1, you can get rid of the denominator, so you can just write your final answer as x plus 9. Blank denominators are perfectly okay. Blank numerators are not. So if there's nothing left in the numerator, there's a 1. If there's just a 1 in the denominator, you can get rid of the denominator. Now for this next problem, hold on, I'm going to risk changing the ink color. Hopefully this doesn't crash again. This looks really complicated, but this is just a division of two fractions written in fractional form. So this division sign here in the middle, this fraction bar in the middle, can be thought of as division. If you want to, you can completely rewrite this problem as the top fraction divided by the bottom fraction. You don't have to rewrite it. You can if you want to. But keep, change, flip is going to involve the same idea. This time we are going to keep the top fraction as is. So we're going to keep x plus 3 over x squared minus 4. Then that middle fraction bar, which is the division that I highlighted in red, I'm going to change that division to multiplication. Then I'm going to flip the bottom fraction. So that x cubed minus 8 is going to go in the numerator now. And then that x squared minus x minus 12 is going to be in the denominator. Then what we're going to do is we're going to factor everything that we can possibly factor. So x plus 3 is not going to get any better, so I'm going to put parentheses around it. X squared minus 4 is a difference of squares, so I'm going to factor it as x minus 2 times x plus 2. I don't know why the subtitles cut out. Hopefully it's still listening to me. Anyway, then for the second fraction, for x cubed minus 8, we're not going to be factoring anything like this in this class. If you take college algebra, you will factor things like x cubed minus 8. But for now, because this is not a course objective for this course, we're going to leave this alone. And then we're going to factor x squared minus x minus 12, which is going to have an x here and an x here. Looking for two numbers that multiply to negative 12 and add up to negative 1 are minus 4 and plus 3. Now, keep in mind, some rational expressions really reduce by quite a lot, and there's a lot of reducing to do. However, sometimes there's not a whole ton of reducing to do. This is one of those. So this x plus 3 can cancel out with this x plus 3, and that's it. So let's just multiply what's left over in the numerator. So we have 1 times x cubed minus 8 is x cubed minus 8. Then in the denominator, we have x minus 2 times x plus 2 times x minus 4 times 1. Just smush them all together with multiplication. You do not have to FOIL all of this out. In fact, I really don't want you to. You can leave it like that. This is completely fine. You do not have to distribute the denominator. Don't waste your time. So then for this last problem is going to involve some more advanced factoring. But what we're going to do is we're going to take care of that division first. We're going to keep, change, flip first. So I'm just going to leave everything alone and I'll worry about factoring later. So I am going to keep that first fraction as it is, 2x squared plus 5x plus 2 over 2x squared plus 3x minus 2. Then I'm going to change that division to multiplication, and I'm going to flip the second fraction. So when I flip the second fraction, that will give us 2x squared plus 7x minus 4, and then over 3x squared plus 13x plus 4. Then from here, I'm going to factor everything that I possibly can. And for all of the factoring here, for both the numerators and the denominators of both fractions, the leading coefficient is not 1, and there is no GCF. So all four of these factors, all four of these polynomials in both of the numerators and both of the denominators, they are all going to involve the AC method for factoring. The AC method we covered back in Chapter 5, that was Section 5.3, involves you taking the first number and multiplying it by the last number and then factoring by grouping. Because I'm running out of room and this video is getting a little long and the last thing I want is another crash, I don't want this video to get too long in case my computer decides to crash again. So I'm just going to go ahead and show you what these look like factored. If you need help with the factoring, please feel free to email me. So 2x squared plus 5x plus 2 is going to factor as x plus 2 times 2x minus 1. Again, this is the AC method, 2x plus 1. Again, this is the AC method that involves factoring by grouping. Then for 2x squared plus 3x minus 2, this is going to factor as x plus 2 times 2x minus 1. Then for the numerator of the second fraction, for 2x squared plus 7x minus 4, this is going to factor as x plus 4 times 2x minus 1. Then for the denominator of the second fraction, for 3x squared plus 13x plus 4, this is going to factor as x plus 4 times 3x plus 1. Now that everything is all written as multiplication and we have this fully factored, we can cancel out any common factors in the numerators with any common factors in the denominators. And there's a lot that cancels out here. So x plus 2 can cancel out with x plus 2. X plus 4 can cancel out with x plus 4. 2x minus 1 can cancel out with 2x minus 1. So let's multiply what's left over in the numerators. We have 1 times 2x plus 1 times 1 times 1 is 2x plus 1. Then in the denominator, 1 times 1 times 1 times 3x plus 1 is 3x plus 1. Remember, resist the urge to cancel out the 1s. Those are common terms, not common factors, and they don't count. So that is now your final answer. So that wraps up section 6.1. I'm sorry that this had to be broken up into 2 videos because of my PC crash, but hopefully you have made it through all of this. So remember, if you want to take notes using the note outlines that are posted on Canvas, please feel free to follow along with these video lectures and take notes as you normally would in class. On Canvas, I have also posted, for your convenience, a completed note outline with all of the solutions all fully worked out. So please feel free to reference that as well and use that if you want to. So I hope that you enjoyed this video and I hope that it was valuable for you. If you have any questions about this video, I did disable comments because it is a public video. So if you have any questions on this video, please feel free to either email me or message me on Canvas. Just let me know what video you're referencing, and if it's a specific question about something, include a timestamp. It would help me out a lot. So thank you all very much for watching, and I will see you guys in the next video for section 6.2. Bye-bye.